In this session, the title is Initiatives to Improve Code Integrity to Continue Providing New Value. I'd like to talk about Yahoo Japan weather app. First, I'd like to introduce myself. My name is Ryosuke Ohmae. My job is to develop Android app, and this is my hobby as well. So in my job and my private life, I enjoy development of apps. I have an account in GitHub, Twitter, and Twitter. Please refer to them if you are interested. And at Yahoo Japan, I'm an Android app engineer to develop Yahoo Japan weather app, Android version. So code integrity is very important to provide new value. One-time release is not the end of applications. You have to continue to provide new value. And for that, of course, you need to develop new features. But it's not only a new feature development what is important. To do so, to improve code integrity is very important as well. Probably the initial design was not good in some cases, but sometimes you have new OSs, and also you have new features, and also new design concepts. You have to incorporate all of them because appropriate status is usually continuing to change. So code integrity is important for every software. If you don't do it, development efficiency is deteriorated and you cannot provide new value. In this session, I'd like to focus on the integrity of codes. With Yahoo Japan weather app, we have new development, and at the same time, we have improvement of code integrity to repay technological debt. 3 years ago, I joined this team, so please compare the apps. The appearance is very different, but it's not only the appearance. Drastic refactoring was not done for a long time, and also the design was done when the know-how of Android was not abundant, so there were a lot of technical liabilities. And we capture better design concepts, and within 3 years, all of the codes were rewritten, and that means we repaid a lot of technological liabilities. It's not something very special what I was doing for the weather app. I was doing only ordinary things. However, this is very important. So from here, I would like to talk about difficulties for apps and also improvement of code integrity. And I would like to talk about 3 points: specification and design, framework and code design, app lifespan. Those are the 3 points. This is a unique story about Android app development, but the basis is not only for Android. This story is common to all software development. The first one is specification and design. So from the engineer's perspective, when you look at this Android app, I thought I noticed something. It didn't really look like Android app. With UI development for a native app, we have switches, checkboxes, and radio buttons, such standardized UI components, and you can combine them to make an app. And also configuration of the images and display. We have some policies presented by platformers. For example, Google Material Design for Android. And using them, you make UIs only for the app. But if you are not using standardized components, and if you do proprietary implementation, that is possible. But when you are not standardized, sometimes your app is not really looking like Android. One of the causes is knowledge, the shortage of knowledge of the developers, because you need a lot of knowledge to develop Android. Right now, smartphones are very popular, but smartphones have only a very short history. At the time, at the first, we didn't have Android app engineers. We didn't have any official documents, and there was no understanding about Android SDK, and people didn't know about UI components or didn't know how to use it. Standard SDKs and Jetpack, and in the past support library, and those SDKs can be usable, and also sometimes you use third parties libraries. But you need knowledge to use all of them, and you need knowledge to use design guideline. So you always have to study, and you can capture the new knowledges. And another reason why you are making apps which are not really like Android, this is a unique issue only in Japan.
The existence or the presence of iPhone. I might be sidetracking a little bit, but there is one instruction that upsets an Android engineer. Make it the same as for the iPhone. That is the direction the Android engineers might not like. And if you're an Android engineer, you might understand. We cannot help this to a certain degree, because in Japan, when you look at the market share between Android and iOS, of course, it depends on how the survey is done, but iOS is used more. And of course, the OS with a larger market share will take the precedence. And also, the persons thinking about the specification and design might just know about iPhone. And if he or she knows only about iPhones, then the specification difference might be considered as a malfunction. And therefore, different specifications might be determined according to the iPhone standards. And many engineers are really honest type of people. And when they're instructed, then they would try to satisfy that request. And if they're asked, can you not do it? And they would say, oh, of course we can. And at the end of the day, we have something in UI that is not like Android. So UI like Android, it might be difficult to make, and you might think it's still acceptable. Well, first of all, this is difficult. That's not good. But not just for the engineers, but for the users, it's not necessarily good. There are so many different applications out there, Android version, iOS version. We have many cases where the same application is provided for both. Now, let's think in the views of service makers, and then the people who make or develop the services will just think about the OSs. And you might think, oh, well, we're talking about the same service, same app. Why not have the same specification? But let's say a user has both iOS and Android devices, but do they actually have the same apps in both? No, I don't think so. Users would have a particular app only in one of the devices. And maybe they're not really thinking about OSs like iOS versus Android. Rather than iOS, they think they have an iPhone. Or rather than Android, they're thinking, I have a Pixel, Xperia, Galaxy, and so forth. That's the mindset of a user. And within one device, in addition to the platformers, official applications within the OS, and the OS functions are there, and also there are third-party apps that they're using. And so from the users, commonality across devices are not much of an issue. They don't really pay so much attention. And so they have to use the apps in the OS or official applications that come with the OS. And if the UI layout, among others, are not unified, then it would be difficult for the users to use it. And of course, brand color should be the same for the service. However, once they switch devices, it might cause some confusion and unfriendly to the user. And I think it's important that the UI rule should be something that has a high compatibility with the OS, while we have a integrated service color. So using a standard component, I think that would be the best for the engineers because he or she can develop the application better, and it's the most sound situation. It's not like the engineer doesn't want to do his work, but rather the cost of development will be lowered, and also it's rather straightforward. Maintenance costs can be reduced, and because it's widely used, usability is good, accessibility is also high, and that means a more complete application can be developed at a low cost. In other words, straightforward use of the standard components has that much benefit. In other words, Android application should be like an Android app. The OS compatibility versus specs and designs. Sometimes they oppose each other. And if you just put importance on only one side, then you don't end up having a good application. You have to therefore talk with the different players, understand their intentions, and reach the best compromise. And by understanding each other's intention, engineer will then make a proposal that is high in terms of OS compatibility, and also easy for the users to use, and less in terms of maintenance costs, and high in quality.
Code integrity requires healthy specifications and design. For example, you can actively introduce design guidelines and libraries and learn how to use them appropriately, or you can achieve a high level of completeness with straightforward implementation and strong OS compatibility. Or we can share specification and design intent, and our engineers propose specifications with strong OS compatibility. So that makes integrity of code based on healthy specifications. Next one is framework and code design. There are many difficulties in Android app development. The first one, as in one package, you need to implement everything. So that means the build package, finally, it becomes one binary. It's the same meaning. So it depends on how you develop it. Actually, you can implement a lot of different features as one. And that makes wrong commonization issue, especially activity and fragment, such components that make Android display. When you implement all of them all together, that makes base activity and base fragment. I am not saying extension of activities and fragment are something you shouldn't do. However, when you do it, overall applications might carry technological debt. And with weather app, base activity and base fragment exist. And it took me 2 years or so to remove every one of them one by one. The next one is about lifecycle and threads. I think this is the same for every field. You have to understand the life cycle of main components, and you have to treat them properly, and that makes a very skilled engineer. On the screen of Android, the life cycle is very unique, so you have to understand it properly. For example, the screen rotates, and that regenerates the instance. And the status handover for that is important. And callback reconnection requires some procedures as well. In terms of threads, UI component cannot be manipulated outside of main threads. And you cannot do network processing in the main thread. So most of the apps should access API. And between threads, you have to transfer data to display the data on the screen. It's very difficult for people who don't know about Android. The next one is the wide range of support. Per version of OS, API changes for Android, and that is expressed as API level values. Major versions do not change always, but even if they say they have the same major versions, API levels are different, so engineers have to look at API levels. For the weather app, we are using Android 13 to Android 7. In terms of API level, it's from 33 to 24 that are supported. So that means you have to look at 10 different types of OS versions. And also, for Android, a lot of different manufacturers are releasing different terminals and devices. So the variation of the hardware and the variation of the size of screens has such a variety, and also each manufacturer has their own unique features for the OS. So you have to address different behavior of the devices, even if the version of the OS is the same. So you can use what is available, and also you can make some functionalities into the mold. That means you can use existing OSs and services actively to maintain modern development environment around Android. There are multiple good OSs that can address the difference between OS versions and devices, and also lifecycle approach and threats. And a lot of apps are using them, so actively I am using it, so no reinvent of the wheel. And in terms of development language, there was a big change. In the past, we were using Java 100% for code, and right now we are using Kotlin 100%. The support was announced as an official development language in Google I/O 2017, and in 2019, Kotlin first was announced, and this is a remarkable development language, and the specification is very good, and it has abundance of standard library for developers to make safe and simple descriptions. The code integrity is largely improves. Another one is fit into the mold. That means architecture. And I have introduced architecture, referring to the layered architecture. The most important thing about architecture is that you don't have to think about how to organize modules every time. For those of you who develop first, if you look at the code that is organized with specific roles, you can make the same modules with the same kind of roles. And also you can limit the scope naturally, so you don't have to fall into local optimums. However, to introduce that, you have to bear some cost. For the implementation, you have to think about many different things. And for re-architecturing, you have to be ready for rewriting all codes. But if you can implement it, your development effort becomes very simple. Work hard and have fun, or have fun and work hard. When you are going easy ways only, you have a lot of hardship later. So you have to work hard, and then you have fun. So use what is available, and as much as possible, you enjoy working to develop. Every option should not be the best option, but we like to have better initiatives so that smoothly we can develop in the end. The last one is from the aspect of app lifespan.
From the very first release, the smartphone apps needs to update the same package. In case of weather app, for more than 10 years, that has been continued. Of course, we may develop a totally different app and ask the users to migrate. That could be done. However, I'm sure that a lot of users will not migrate to the new app. Therefore, this is not an easy path to take. In other words, we have to continue doing this into the future. So over a very long term, we keep on updating. But when we try to do that, we face a few challenges. First is once out, there would be irreversible elements. We're talking about updates, and maybe it's so different that it looks like a totally different app than before, but still there would be irreversible elements. For example, external protocols. In case of Android, we have what's called the Android manifest. It's a file that stipulates the external specification of the app. How to start the external app, such as a home app or widget-related information is written here in this Android manifest. And what's been written there is to be used from the outside of the app. In other words, if you easily update that and change it, then it's not going to work properly. There's that possibility. For example, changing the name of the class of the screen that you're starting, that could happen quite easily in refactoring. Once this happens, the user-generated shortcuts might be gone or disappear, and it may remain, however, the app may not start properly. So these are some of the possible issues. And also another is about persistence information. Setting of the app, what's been stored in the local storage, will stay even if update happens, and therefore that element could be irreversible as well. So once outside the app specifications cannot be eliminated totally, and that ends up as a debt. So things that have gone out of the app, such as the past app specification, is invisible from the current app code. If it's about coordination, the information as to from where that is used, that information will no longer be found in the code. You think that this service is no longer used. However, is it totally unused? You cannot be so sure. Therefore, you just try to keep it just in case. So there are such codes that remain for a long time. And also past persistence information is another issue. There is a key value data structure called share prefecture in Android. This is an arbitrary data that can be stored, and app setting is stored there. Without proper management, past data that is no longer used will no longer have this information as to what key it was, in what form it was used. And once that happens, additional or new read-write process would have a high risk, because the new key that was added may have been used in the past, and you cannot identify that in tests. And then what happens is that after the release, a problem occurs only in the user devices that have been using this key in the past. So once outside the app, even after the elimination of the process, there would be remaining impact. Also, apps are actually installed into the user's environment, and given that nature, just by changing the package that's been uploaded will not have the changes reflected. In other words, the users themselves have to do the updating for that change to be reflected. However, some users do not update the app because he or she doesn't want the specification to change. It's not just about new features or specifications. We want bugs to be patched or corrected, and also fixing some of the vulnerabilities. And we want all the users to update their devices or apps. But it is also difficult for us to force the users to do the updates. And therefore, we might think that data structure is different, therefore migration is needed, but that migration cannot be executed unless the user updates the app. And therefore, the old data structure lingers and stays in the market, and that makes the problem all the more complex. For such issues, you cannot really make this code more sound or healthy just by looking at the application codes. So there are puzzling specs from the past. These puzzling things that have been developed still remain, so you cannot do anything about that. You have to actually install logs, interview people who are involved. In other words, very analog approaches need to be taken to search and understand how or if they are indeed used. And if they're not used anymore, we should just eliminate the app, including the spec. And well, if there's any possibility of the features still used, although the features are no longer provided, for example, the shortcuts of calling a specific page or screen within the app. That's one example. And we try to keep the overall integrity. If it's a shortcut, but if the support for the destination screen is no longer provided, then we just leave the entry point and just make it possible for the user to start the app, and that's it. And then if there's any new equivalent screen, then we can actually steer the user to that new page and then eliminate the old screen. So we need to get rid of the puzzling screens. There are things or features that we have worked very hard on, but it might be outdated, or it might be really popular at the beginning, but then a few years later, it may no longer be used. So we always have to think about the end state, how that feature will end. So I mentioned the irreversible elements. So for such elements, of course, we would like to, but cannot just get rid of the older specification and switch to the new one. We have to be persistent, spend time so that we will minimize the impact on the users and have gradual changes made. Because there are users that refuse to update, and therefore we have to cope with both the old version and the new version. And migration support has to be provided over a longer term. Migration for each user happens only once. However, for us, we have to deal with the old and the new versions, and that requires us to do checking, processing that could be considered as a waste. So we cannot do this forever. We cannot really keep on supporting until the last user. We have to set a limit. And for the weather app, we set this standard of 2 years maximum. In other words, for users that have not updated it for more than 2 years, migration support will no longer be provided. So for 2 years, no update. And with that person, all of a sudden switch to the latest version? No, that's not likely to happen. And it's possible that that person has bought a new device, because 2 years is a period in which the features have dramatically changed, and it would be quite difficult to actually carry over all the settings. Of course, not providing support anymore doesn't mean that feature is not going to be available. It's only about the set values going back to default values, for example. And so in order for us to update the features, it's important that we make a decision as to when to stop supporting. And if we can set a standard for that, it would make things easier for us. As I have said, there are irreversible elements coming from the past specifications, and for a long time we have to support both the old and the new versions. And of course, we need to have that margin, so to speak. However, the internal codes design shouldn't be influenced by that. And for that issue, architecture can be useful, separating or isolating the inside and the outside of the application, and establish a layer for conversion, and also make sure that the inside doesn't impact the external specification, so that we can actually keep the integrity within the app. And towards the future, the persistence data design and protocol design stages would also consider migration of the future. This is something to be given, but version numbers should be attached to every protocol or data, and also any feature will become obsolete, and they would have to be reworked on. And we need to therefore always be mindful of the end state so that migration is possible. In other words, we need to think about avoiding debt in the future. We need to make sure that specifications will not have a negative impact in the future. We tend to focus on the current state, how to make that thing that we're working on, but we need to think about the future maintenance cost and try not to leave any negative legacies behind. And so applications have long lifespan. We have to keep on updating, but we have to do a stock taking of the past specs and be persistent, conducting migrations in a longer span so that we have less debt, technically. So I have looked at 3 aspects of enhancing code integrity. It has to be a sound specification, use what is available, and make efforts so that you don't have to have problem in the future and be efficient, and also put an end to the past and have no negative legacies going into the future. So do ordinary things as a matter of course, and that is really the key to improve code integrity. Thank you.
ありがとうございました。
Mr. Ohmae, thank you very much. From here, we would like to have the plus talk. We would like to focus on some questions to deepen the discussions, and we would like to take up your questions as much as possible to proceed with the discussions. If you have any questions, please use the question mark button on the screen. So please send us your questions. Mr. Minetoshi Ishikawa offline to ask questions. Mr. Ishikawa? Yes, thank you very much. From line, I am here, and I'm doing Android client development. My name is Ishikawa. Thank you. So, Mr. Ishikawa, listening to the session, what is your impression? What kind of question do you have? It was very interesting. Thank you very much for the presentation. In line, I am developing apps. So how to repay technological debt to improve value is a big challenge for myself too. So I really feel for you too. I have some questions. My first question is about the framework and the code design. So what is usable you are using? You said what is available. Yes, of course, what is available you can use. So you don't have to implement every code. To minimize the number of code implementation is very important, I guess. But as was on your slides, reactive X and live data and gluten. So one status is observable, for example, and I think you can use all of them. In that sense, how do you differentiate what to use and what not? And so do you have any policy to use what for what kind of cases? How do you decide on that? That's my question. Thank you. For reactive programming, nowadays we have very good libraries. Every one of them is very good, so I sometimes wonder which one I should use. And as for the weather app, when we thought about the improvement of code by using this kind of architecture, Kotlin was kind of in the experimental stage. It was kind of premature for us to use it. in our environment. And in those days, RxJava 2 was more widely used. So that is what we have started to use because it was hard for us to use experimental product for our production code. So we wanted to use something more mature. RxJava could have been used for all of us, our code. But when we wanted to use it for UI, we found out some inconvenience because it couldn't be used for the entire lifetime. So we decided to use RxJava and then live data for the UI type. That is how we have differentiated and Kotlin. And nowadays we switched to Kotlin because the library is very fulfilled. Yes. So we would like to move to Kotlin, but we haven't yet. But we would love to. Yes. Thank you.
Okay, so related to that, a new architecture comes out, and then you migrate to that new architecture. I think continuing on that path is important, but in this case you just described, during the migration, a new one might come up again, and then there might be partial use of the new architecture or new use of the library. In other words, within the same app, consistency might be lost. I think that can happen quite often. So in that kind of a case, what do you do? Well, basically, a new mechanism or asynchronous part, the overall policy has to be determined. Until then, we try not to introduce anything new. And experimental use or trial is done partially, and if we know that it works, then we apply it in a full-fledged fashion. In other words, we try not to use multiple ones. Okay, I understand. Thank you. Then, so next experiment would start only after everything has been subject to the application. Yes. RxJava based refactoring settles, and then we're ready to think about the next. So that's what we're where we are at now.
So when you migrate, you have to use a lot of resources. So hardship first, and to make it easier later, you were talking about it. But for the migration, you have to use a lot of resources, and you have to convince people about it. I think it's important for you to convince people around you. And how did you do it? Yes. It should depend on what kind of app. But in my case, well, I write a graph to explain hardship first, and later you're going to make it easy. I just explain and I try to convince people. That's very interesting. That's very interesting. I'd love to see the graph, and I'd like to attend the explanation meeting. Yes, it takes time first, but this graph shows it's going to be very hard later, and I can show the hardship first makes it easier later.
And there is one question coming from the audience. NESCK version, how do you decide on that? Can you address that question? Well, a clear standard is not set, but one reference we make is Google activities. Google official application seems to have changed that to SDK, and then if we catch that, we think about the trend of the users. So it's not just about technical decisions we make, but we have to think about the service aspects. And we really consult this matter to different players. For example, do a search as to a number of users before making that decision. Okay, a related question, a personal question from me.
SDK は基本的
So me SDK is to cancel the apply binary support. But as a service, to what extent the binary version is supported, those two are different story. So if you upgrade the version of me SDK, well, you have to support this the other part. This is a trade-off. How do you address it? How would you control it? So the latest Me SDK version for the development, and are you talking about old version with support still? Yes. We do not have any specific criteria for that, but we keep the old version and we check how many users, the reduction of users, and we stop it. And if the security is not guaranteed, we just decide not to use it. That's a very reasonable idea. Thank you.